Lesson 2, significant digits. And we start out with a question. What's the difference between $600 and $599.87 besides the 13 cents? And the answer is one of these figures is more precise than the other. Scientifically, we say that one has more significant or relevant digits than the other. 600 has one significant digit. We often just say Sig Fig for significant figures. We shorten it, so we'll talk about Sig Figs. $599.87 has 5 significant digits, or Sig Figs. What are the rules for Sig Figs? Any non-zero number counts. 456 has 3 Sig Figs. 0.9723 has 4 Sig Figs. $302 has 3. There's a 0, but it's in between two other numbers, so we count it. 302, that has 3 Sig Figs. That has 3 Sig Figs. That still has 3 Sig Figs. Still has 3 Sig Figs, because those zeros afterwards aren't actual values that you measured. What they are, Hakeem, is placeholders. They tell you whether it's 1,000 or 100,000 or 10,000, but they don't actually mean measured values. Zeros to the left of a decimal point count. Is there a decimal point right there? That has 3 Sig Figs. Is there a decimal point right there? No. That has 2 Sig Figs. Don't worry, it'll become clear. Turn the page. Zeros to the right of a decimal are tricky. You didn't just say a bad word, did you? No, you never would have said a bad word, ever. If there are non-zero numbers to the left of a 0, they count. Otherwise, ignore them. So, here's our decimal point right here. This here, we would say, has 4 Sig Figs. Five Sig Figs. Two Sig Figs. Three Sig Figs. Any guess here? 4 Sig Figs. Yep. And by the way, it's hard for me to give you an English rule. It's much easier for me to give you a bunch of examples, and then you'll go, oh, I see what he's getting at. Okay? So, how many Sig Figs? 3. And the reason is the fact that what we have to realize, Sig Figs are designed so that I can use 2 different instruments in a lab and compare measurements, even if they have different levels of accuracy. The fact that I put a 0.0 there, what I'd be saying is whatever instrument that I was using was actually accurate to 1 decimal place. And so when I measured it, it actually was 63.0. I got that measurement.
Wouldn't the other one be 6 then?
When this one here?
No, go back to that.
Go back to my example.
Yeah, wouldn't that one be 6?
1, 2, 3, 4. I'm sorry, can't count. I never make mistakes. 6. Ooh, I'm taping this lesson. That's now saved for internet posterity. How humiliating. You found a mistake. You pointed it out. You get a can. So Matt, Sig Figs are designed to help us compare different types of measurements. What if you're in a lab and you're weighing something and your scale is accurate to 2 decimal places, but you're also measuring with the ruler and the ruler is barely accurate to 1 decimal place? How the heck do you compare those? How accurate can you be? These are the rules for accuracy. And the reason it's not quite as useful here in my high school classroom is most of the time the equipment that we're going to be using is crappy, and inaccurate anyhow. If you get into a nice, fancy, schmancy, good equipment lab, then sig figs and tolerances really do become important. So what are the rules for sig figs? Well, multiplying and dividing sig figs. Suppose that you were measuring something and you got 6.74, and then you measured something else, that same thing with a different instrument, and you got 2.0002. So one of your instruments is accurate to 4 decimal places. One of your instruments is accurate to 3 decimal places. How the heck do you get an answer if you're multiplying them? Well, the first thing you do is you get out your calculator. Hint, hint. And you type in the question. 6.74 times 2.0002, and you get an answer. Where do I round off to? Do I tell you that the answer is 13.481348? No. 13? No. Here's the rule. So first of all, do the math. How many sig figs does this first number have? Let's write a little tiny, very small 3 right above it. How many sig figs does this second number have? 5. What's the smallest number of sig figs we have out of those 2? That's what we're going to go to. We're going to round off to 3 sig figs, not 3 decimal places, 3 tera sig figs. So I'm going to look at my calculator, and I'm going to go 1, 2. I'm going to round off on the 4. Will I leave the 4, or will I round up? What's next to the 4? 8. So will the 4 stay a 4, or will it become a 5? This is the rule for comparing instruments of different calibrations. When you're multiplying and dividing, you round off to the fewest number of sig figs of one of your measurements, which means if one of your measurements only had 1 sig fig because it was really inaccurate, all you can give me as a legitimate answer is only 1 sig fig because you're not that accurate. B, how many sig figs in the 6.4? 2. How many sig figs in the 9.088? What am I going to round my answer off to? 2 sig figs. 6.4 divided by 9.088. Enter. Am I going to say 0.704, No, 2 sig figs. This is why it's important for me to include the 0. Even though there's a 0 there, it's counted as a sig fig because it turns out when we measured this stuff, our answer had a 0 on the second digit, on the second sig fig. I'm going to go 0.70 or 0.70. Zeros in front of the decimal don't count. And let's make that last 0 a little bit neater so it doesn't look like a half of a 6. Okay. 2 sig figs. So the rule, you never round off until all your calculations are finished, and then you round off to the smallest number of significant digits represented. Let's try example 1. 13.567 times 5.56. I'm not going to say the answer of 75.43252. How many sig figs am I going to go to in my answer here? AJ? 3. So what, point, what? 75.4. 0.5, 0.4. Oh, no, it's a 3 next to there, so 0.4. Example 2. 9.088. Now I'm going 13.567 times 5.5. Now I'm going to go to 2 sig figs. Now I get 74.6185, but that's not what I'm going to write as my answer. Perry? Yep. Example 3, 13.567 times 5.0. I probably didn't need to type the 0.0 on my calculator, but just so I can see what the heck I did. I get 67.835. How many sig figs am I going to here? Yeah, 2, not 1. This is 2 sig figs. That 0 meant something there. So I'm going to go, I guess 68 is the best I can do. Example 4, 13.567 times 5. 13.567 times 5. You know what? I'm going to get the same answer as I just got, except how many sig figs can I go to here? 1. So the answer is going to be 70. Isn't that 2 sig figs? No, 0's to the right. How would I, what if I wanted to go to 2 sig figs? What if the answer was 70 with 2 sig figs? I would put a decimal right there, and that would tell people that 0 counts. No decimal there. That 0 is a placeholder. You're 1 sig fig. Multiplying and dividing, Callum, are in terms of sig fig rules, the easier. Adding and subtracting, sadly, is way tougher. In fact, multiplying and dividing, I usually can do in my head and do the rounding off in my head and just get to. Adding and subtracting, I still have to write out. Okay. Addition and subtraction, turn the page, with sig figs. Sadly, the rule here has nothing to do with how many sig figs in your original information. The answer is not going to be to 4 sig figs. It's not going to be to 2 sig figs. It might be, but it might not be. What do you do? Well, the first thing that you do is you actually do the arithmetic. So you don't round off. 4.567 plus 9.0. I'm not going to write the 0.0. And Samantha, I get 13.567. I'm going to write that down, first of all. 13.567. If you're adding and subtracting, Jordan, the easiest way to do things is to write things vertically. And you'll notice as soon as I write things vertically, there's going to come a point, there's going to come a column where I have a missing number, a blank number. I don't have something in both, don't have a number in both rows. See it right there, right after the 0 is the first place, Tara, where suddenly, hey, we're missing something. What that tells me is I can only be accurate to this location right there. You see, I haven't counted sig figs at all. I can only be accurate to the location where I know all of the numbers in the column. As soon as the number is missing in the column, I can no longer be accurate to that decimal point. So my answer is going to be 13 point, well, I'm going to round off to there. Is it going to stay a 5 or is it going to round up? William, how many sig figs in my answer? 3. Were there 3 sig figs in any of my question? Nope. Let's do another one. If I ask you to add 6.4321 and 5.639 and 4.12, 6.4321 plus 5.639 plus 4.12. The first column where I'm missing something is this one right here, which means I'm going to be accurate to this decimal point right here. I'm going to round off properly, looking at what's over here. Going to go to my calculator. 6.4321 plus 5.639 plus 4.12. So I get 16.1911. I'll write that down. Whoop. Try that again, Mr. Dueck. What was it? 16.1911. I can be accurate to this column. I can be accurate to this column. I can be accurate to this column. I can't be accurate to this column. The 9, is it going to stay a 9 or is it going to round up to a 0? Stay a 9. 16.19. Final answer. 4 sig figs, which happens to be the number of sig figs of the middle term, but that's just a coincidence. Do you see why, when you're adding and subtracting, it's really better to write them vertically, because then you can see the columns? If you get good at it, you can kind of imagine writing it vertically, Michael, and do the math. Not worth it for me. So what's the rule? Use all the known digits in the calculation. Don't round any off yet. Round off to the last decimal place that both or all of the numbers have in common. Round off to the last column where you know everything in that column. Okay? So if you're adding 4.567 plus 9.0, here's the 2 that I don't know. I get 13.567. Nope, I'll round off to 13.6. Let's try one on your own here. Example 2. 14.389 plus 12.6314 plus 2.58. You'll find it easier to rewrite it vertically, keeping your decimal points all nice and lined up. With 2 zeros. Check, check, check. Check. Yes? Yeah? No? Yeah? Am I right? Okay. Elijah, maybe you can see when you get good, you could have said 3 decimal places, 4 decimal places, 2 decimal places. I'm going to round off to 2 decimal places. You can get good enough to do these without rewriting them. And in your homework, if you want to challenge yourself that way, knock yourself out, on a test or a quiz, I always write them vertically, and then I can clearly see where I'm missing a column and what to round off to. Is that all right? Okay. Sig figs. Having said that, the multiplying dividing rule I think is way easier. Okay, how many sig figs? What's the fewest number I have? That's what I go to. And most of the time here in Physics 11, most of our equations are going to be multiplying and dividing. And we're going to kind of get sloppy with sig figs. I'm going to teach it to you, but I'm not going to be taking marks off on tests and quizzes and things like that. I'll just try and be consistent when I'm doing questions and try and do them to the right number of sig figs. Turn the page. Homework assignment number 1, number 2, and then once you've circled both of those, put your pencils down for a second.